In this video, we're going to solve CAPE 2024 Pure Maths Unit 1, Question 3. Part A reads, express 5 sine theta plus 12 cosine theta in the form r sine theta plus alpha, where r is bigger than 0 and 0 is less than alpha less than 2 pi. First thing you should see is when 0 is less than alpha less than 2 pi, that means that alpha is in radians. Just make sure that your calculator is always in radians for questions like these, because if it's in degrees, you're just going to have the wrong answer. So that's an important thing to just double check. Okay, so now to solve this, what we're going to do is we're going to write 5 sine theta plus 12 cosine theta is equal to r sine theta plus alpha. And our job is to solve for r and alpha. The way we're going to do that is we're going to expand the right-hand side using the sine sum formula, which is r sine theta cosine alpha plus r cosine theta sine alpha. I can rewrite this as r cosine alpha sine theta plus r sine alpha cosine theta. And I want this to be equal to 5 sine theta plus 12 cosine theta. So what I'm going to do is I'm going to equate the coefficients. So for example, the coefficient of sine theta on both sides, on one side is 5 and on the other side is r cosine alpha. So what I'm going to say is r cosine alpha equals 5. And similarly, the coefficient of cosine theta is 12 here, and then the coefficient of cosine theta is r sine alpha. So the next equation is r sine alpha equals 12. I just have to solve these simultaneously. So the first thing I can do is I can square, let's say this is equation 1, and this is equation 2. If I do 1 squared plus 2 squared, I'm going to get r squared cosine squared alpha plus r squared sine squared alpha equals 5 squared plus 12 squared. And we know that cosine squared alpha plus sine squared alpha is always 1. So that just means that r squared is equal to 5 squared plus 12 squared, which just means that r is the square root of 5 squared plus 12 squared. And if you just put this in the calculator, you're going to get 13. So that's r. And then what's alpha? Well, if I take 2 divided by 1, I get sine alpha over cosine alpha. And sine over cosine is just tan alpha is equal to 12 over 5. So that means that alpha is just tan inverse 12 over 5. And you'll see that this is 1.176 radians, right? So the way that you'd express it is 5 sine theta plus 12 cosine theta is equal to 13 sine theta plus 1.176. Okay, so that's how you do part 1. Part 2 asks us to show that 5 sine theta plus 12 cosine theta plus 7 is less than or equal to 20. So usually when you have this question and the next part is some kind of inequality, you have to use the first part. So the way that we're going to do this is we're going to just use what we just figured out from the first part. So 5 sine theta plus 12 cosine theta plus 7 is equal to 13 sine theta plus 1.176 plus 7. And the next step is that we have to realize that sine theta, the important thing that you need to know about both sine and cosine is that sine theta is always less than or equal to 1 and greater than or equal to minus 1. But in this case, what we really just need is that it's less than or equal to 1. So I can say that this is less than or equal to 13 times 1 plus 7. And 13 times 1 is just 13. Plus 7 is 20. So indeed, the expression is less than or equal to 20, like we're asked to show. So now do part B. Part B first asks us to show that 2 sine x plus 3 cosine x equals 3 can be rewritten in the form 13 cos squared x minus 18 cos x plus 5 equals 0. So if you look at the thing that they're asking us to show, there is no sine x. So basically what we have to do is get rid of sine x. And the way we're going to do that is by the trigonometric identity, sine squared x plus cos squared x equals 1. So how do we do that? Let's start with our equation. 2 sine x plus 3 cosine x equals 3. Let's then move the cosine x to the other side. So 2 sine x is equal to 3 minus 3 cos x. Now let's square both sides. 4 sine squared x is equal to 9 plus 9 cos squared x minus 18 cosine x. Now, the way I expanded this right hand side is 8a minus b all squared. So that's a squared plus b squared minus 2ab. Now what I'm going to do is I'm going to say, okay, this is 4 times 1 minus cosine squared x equal to 9 plus 9 cosine squared x minus 18 cosine x. And then, okay, this is 4 minus 4 cosine squared x is equal to 9 plus 9 cosine squared x minus 18 cosine x. And then if I just collect the terms on the right hand side, I get 0 is equal to 13 cosine squared x minus 18 cosine x plus 5. And that's the exact equation that we're asked to show. Now let's move on to part 2. We're asked to solve this equation. The same equation for minus pi less than or equal to x less than or equal to pi. Keep in mind, once again, this is in radians. So the way that we're going to do that is we're going to use the same form, the form that we just found. So we've just shown that it's the same thing to just solve 13 cosine squared x minus 18 cosine x plus 5 equals 0. If I was to let y equal cosine x, then this is like 13y squared minus 18y plus 5 equals 0. This is a quadratic, solve that however you want. The one way that you can do it is you can factorize. If you factorize this, you're going to get y minus 1 times 13y minus 5 equals 0. And then that means that the two solutions are y equals 1 and y equals 5 over 13. But we're asked to solve for x, so we can't just leave it like that. So this cosine x is equal to 1 and cosine x is equal to 5 over 13. Let's do the cosine x is equal to 5 over 13 first. You have to, the first thing that you should do is figure out what the principal value is. If you were to just do cosine inverse of 5 over 13 in your calculator, you get 1.176. Now, here it's cosine x is positive, so if we draw our quadrant, it's going to be ASTC. All school teachers care, that's how I remember it. And cosine is positive, so the two ones that we care about are this one and this one. So we have to figure out what angle. So the first thing is we just showed that this would be 1.176. And then the next one is we have to figure out, well, what angle is that? If you look at the range though, they said that the angle is allowed to be negative. So actually our angle will just be the negative of this, minus 1.176. So those are two solutions corresponding to that value of cosine x. The next one is for cosine x is equal to 1. For this one, what's the principal value? The principal value is actually just 0. If you put cosine inverse of 1 in your calculator, you just get 0. So now, in the same thing, the angle is actually just here. And even in the fourth quadrant, it'll be the same thing. In other words, because minus 0 is 0. So actually, the only solution here is just x equals 0. So these together are the three solutions for this equation. Let's move on to the last part, which is a trigonometric proof. It asks us to show that 2 cos squared x minus 1 squared all over cosine 4x minus sine 4x is equal to 1 minus 2 sine squared x. I suggest when you have to pick a side to start working with, you pick the side that's a little more complicated, because usually it just means that you have more things that you can work with on that side. If I start with 1 minus 2 sine squared x, what can I do then? Seems a bit difficult, but the left-hand side, because it's complicated, there's so many things I can try. So let's start with the left-hand side. That's 2 cos squared x minus 1 squared all over cos 4x minus sine 4x. The denominator is the difference of squares. What that means is I can write it like this: 2 cos squared x minus 1 squared all over cos squared x squared minus sine squared x squared. And a squared minus b squared is equal to a minus b times a plus b. So I'm not doing anything with the numerator. What I'm saying is that this is cos squared x minus sine squared x times cos squared x plus sine squared x. But cos squared x plus sine squared x is 1. So I can say that this is equal to 2 cos squared x minus 1 squared all over cos squared x minus sine squared x. Since cos squared x plus sine squared x equals 1. So now what I'm going to do is I'm going to replace this sine squared x by 1 minus cos squared x. So if I do that, all over cos squared x minus 1 minus cos squared x I actually see that what I get on the denominator is actually the same thing as what I had on the numerator. It's 2 cos squared x minus 1 all squared all over 2 cos squared x minus 1. So that means that I can just remove 1 from the power of the numerator, so it's just 2 cos squared x minus 1, and I'm really close. But the only thing is my expression is in terms of cos squared, and the right-hand side is in terms of sine squared. So what do you think I'm going to do? I'm just going to say, okay, well, cos squared is 1 minus sine squared x. So 2 times 1 minus sine squared x minus 1, which is equal to 2 minus 2 sine squared x minus 1. And then if I collect the 2 and the 1, that's just 1 minus 2 sine squared x. And boom, that's exactly what we wanted to show. So we're done.